calculus, we begin with secant slopes, approachment, and limits, and how these can eventually bring us to this main idea of how we find a tangent slope at one point. Pictured below is the graph of some random function. Taking 2 points, a secant line, we are going to now find the slope of that secant line. In order to find the slope of 2 points, you need to find the y value of b minus the y value of a over the b value of x minus the a value of x. This, in conclusion, shows it is rise over 1. Doing the calculations, we get -3. Because we now know how to find slope at 2 points, we come back to our main question or our main idea of how we find the slope at 1 point. Doing so, reading from the same graph, we will be able to find the 1 point using approachments or limits. So for point B at x equals 2, we know that the slope is 3. To test this for approachment, you can see the grid on the left-hand side of the page. So we take numbers from the left-hand side of the graph, approaching 2, getting bigger and bigger until 2. And as we can see, as the function approaches x equals 2, from the left, it gets bigger and bigger. As you look from the opposite side, with the green arrows, you can show that from the right, it's the same thing. It's getting smaller and smaller, though, to approach 3. So can this show us that it is a limit? Well, let's dig in further. From what we learned in class, we can show that limit of f of x as x approaches a equals L, as it gets closer and closer to the number from both sides. Now this only occurs when it happens from both sides, because if from one side it is not the same, the limit will not exist. Now that we know that this limit exists, we come to the realization of what do we do with this, or what does this mean? And what this actually shows us is one of the most fundamental things of calculus, and what we spend most of our time in Calc 1 focusing on, the derivative. The derivative is extremely important to us in our life because the derivative allows us to show us the instantaneous rate of change at one point in a graph. This allows us to know at any single point what that change will be. This is very useful in many aspects of the world, such as physics, science, cars, and anything dealing with velocity, time, acceleration. The derivative, or f prime of x, can be shown below in many different forms, but it all means the same thing, f prime of x. All in all, this project is to show you that this huge thing, the derivative, which we make our prime example of knowing how to do in Calculus 1, is all derived from finding the limit or approachment of a point on our function. And that point's slope is its derivative.